Okay, so we've done something like this with sine and cosine of some angles, working forward and backward. And then here we'll just try the same thing with tangent and cotangent. The geometric approach of width and height and slope can help us approach these as well. Just with tangent and cotangent, we're focusing more on the slope part of that rather than the width and height. So we'll try these over here on the left, and then you can try the ones on the right on your own. So the thought process that I go through here is I just imagine a unit circle, and I know that pi is over here on the left, and remembering the tangent of an angle is the same as the slope of the radius I just drew. Well, I go back to my algebra or even pre-algebra skills, and I say, well, that's a horizontal line, it has a slope of 0, and I am done. I don't have to do any division and y over x business, just horizontal, slope is 0, finished. A slightly more interesting one is going to be here where we land inside a quadrant. The over 3 tells me that we're looking at one of the steep radii, which actually tells me something about tangent already, and therefore cotangent. But let's go ahead and graph this. So I know that it's steep, and then 4 pi over 3, or 4/3 pi, is more than pi, so I know I'm down here. And so I'm going to start not by finding cotangent, I'm going to start by finding tangent of that angle. Just by looking, the radius I'm drawing goes uphill from left to right, so it has a positive slope. And we said very early that it was steep. And so out of my tangent options, 0, undefined, or kind of the two extremes, 1 over square root of 3, square root of 3. So if I'm looking at a steep slope, I pick the big one. But that's for tangent, and I wanted cotangent. Well, easy enough, flip it upside down. Either as 1 over square root of 3, that's a fine answer, or if you rationalize square root of 3 over 3, it's also correct. So here, instead of thinking about width and height, or sine and cosine, or x's and y's and division, this was really just a slope question. After I finish talking here in just a moment, hit spacebar or hit pause and try these two examples on the right. And then when you're ready, just unpause and I'll have answers for you. And there you have your answers. 3 pi over 4, I just sketched that over here. The over 4 told me it wasn't super steep, it wasn't super shallow, so it told me to go smack dab in the middle with a 1. And then the visual, that radius has a downhill slope from left to right, so I went with -1. For 0 radians, or 0 pi radians, it's over here on the right. So I started with tangent, and that horizontal tells me that tangent of 0 radians is 0. And when I flip that upside down, I got undefined. Let's use that to work backwards here. And just like we did in the sine and cosine example, let's stick with 0 included to 2 pi excluded. Over here on the left, walk through the thought process here. Kind of like what we did with sine and cosine, but again, focusing on slope more than width or height. So I see that tangent is negative. So I'm looking for places where I can draw radii with a negative slope. Here again, I don't need all students take calculus. I just need to imagine drawing some radii. Any radius I draw up here has a negative slope. If I just continue those, anything down there has a negative slope. So that tells me I'm looking at something in quadrant 2 or 4. And then the square root of 3. I know that tangent of an angle is related to a slope. I know that square root of 3 is the steeper option. So I'm going to go with a steep one up here, steep one down there. I know those are my over 3s to be steep. And I know that to land up here, I'm going to be at 2 pi over 3. And to land down there, I'm at 5 pi over 3. And there are my solutions. I didn't have to do any division of y's and x's and kind of trial and error to try to make that happen. It was the yellow told me which quadrants I was going to be in. And then these blue things told me to draw the steep ones, which told me to do the over 3s. And then the quadrant took care of the rest. The next example is weird, but just like we saw earlier, sometimes weird is better. In this case, it makes it easier. Cotangent, that's kind of a pain, so I'm going to flip that upside down, take its reciprocal, and turn that into tangent. And then undefined, certainly something that's undefined doesn't really have a reciprocal, but just based on the patterns we've seen, I'm going to turn that into a 0. We've seen that those kind of work as not real reciprocals of each other, but they kind of work that way. So let's solve this problem by solving this problem that's easier to think about. Here, I'm not dealing with a positive or a negative, so I'm not dealing with quadrants at all. All I know is that I want the slope of the radius I draw to be 0. To draw something with a slope of 0, it needs to be horizontal. So either horizontal to the right or horizontal to the left. So to the right, that gives me 0 radians. To the left, that gives me pi radians. And as we saw in the other video, I'm not bothering with 2 pi, just because of the instructions I had up here at the beginning. It said leave out 2 pi, so I did, but include 0, so I did. And here again, go ahead and pause the video and try that right-hand column, and when you unpause, I'll have answers. And there you have your answers for the right-hand column. You'll notice just how I translated. Saying tangent of an angle is undefined is the same as saying that when I draw the radius, it has an undefined slope, which means that that line has to be vertical. So that landed me at the top and bottom, pi over 2 or 3 pi over 2. For the next one, my first job was just to flip. So instead of cotangent, I flipped so I could talk about tangent. And instead of square root of 3, I flipped to get 1 over square root of 3, which told me I was looking for something that was not steep. And because I had a positive value, that told me I needed a positive but not steep slope. So that told me I needed my over 6s because I wasn't steep. And then to be positive, there's my quadrant 1, and there's my quadrant 3 result. So that is it for this. Again, hopefully that new trick, that different way of thinking about it, has helped you maybe do these a little bit quicker.